Hi children, this is yours Kona Kiran Reddy. Welcome to 8th class mathematics. Now let us see exercise 3.1. First question. Given here are some figures. We are given some figures here. Classify each of them on the basis of the following. A. Simple curve. B. Simple closed curve. C. Polygon. Then D. Convex polygon. And then E. Concave polygon. So first let us see simple curve. So simple curve, what is the definition of simple curve? If a curve does not cross itself, then that is said to be simple curve. That means one line should not cross the other line. So in these diagrams, we need to check what are those curves which does not cross itself again. That means one line should not cross the other. First A, simple curve. What are simple curves? What are simple curves? First you see first one, second one. These two are simple curves. In the third one, it is not at all a plane curve. Why? Because here in this one, we have two separate curves. That means to draw this diagram, we need to lift our pencil. So that means if we draw like this, continuously we can't draw. So we need to lift the pen and we need to draw again like this. So it is not at all a plane curve even. So it is not simple. Then fourth one line is crossing the other so many times. So it is not a simple curve. Then fifth one is also a simple curve. Sixth is also simple curve. So 5, 6, 7 is also simple curve. Then eighth one if you want to draw this, we need to draw two circles like this and after that we need to join. Or otherwise we can draw like this. First draw a circle. Here it is completed. Then once again we need to start here from here like this. So here like this. So it is not a simple curve. So 1, 2, 5, 6, 7. These are the simple curves. Next let us go to B. That is simple closed. Simple closed curve. So here 1, 2, 5, 6, 7. These are simple curves. So out of these 1, 2, 5, 6, 7 which are closed. Let us check that. Closed means if we are unable to judge which is the starting point or which is the ending point like that, that is closed curve. So closed means as the name suggests, closed one, closed. So here 1, 2, 5, 6, 7 all these are simple closed curves. 1, 2, 5, 6, 7. Why? Because all these are closed. We need not to think about 3, 4, 8. Why? Because those are not even simple curves. Next C, polygon. What is meant by polygon? A simple closed curve made up of only line segments. That is said to be polygon. So simple closed curves are 1, 2, 5, 6, 7. Out of these, which are constructed by only line segments, you see. Out of these 1, 2, 5, 6, 7. Why? Because these are simple closed curves. First one and second one. These are only simple closed curves which are constructed by using only line segments. In the remaining three, we have see this is not a straight line and this is not a straight line. This is not a straight line. So we can say 1 and 2 are the only simple closed curves which are made by line segments only. Next D, convex polygon. Convex polygon. So first of all, what is convex polygon? A polygon in which all the diagonals are in the interior of the polygon, then that is said to be convex polygon. So here we need to check just 1 and 2 only. Why? Because those are the only polygons we have in this. So first one, you see, in the first one, if you draw a diagonal like this is in the exterior. So it is not a convex polygon. Second one, you see, you can draw the diagonals like this. So both the diagonals, we have two diagonals here, both the diagonals are in the interior of the polygon. So second one is the only polygon which is convex. So next we have E, concave polygon. So concave polygon means If any part of the diagonal is in the exterior of the polygon, then that is said to be concave polygon. Clearly in the first one, if you draw a diagonal like this is the exterior of this polygon. So clearly first diagram is the concave polygon. Exercise 3.1, second problem. How many diagonals does each of the following have? A convex quadrilateral. First, let us draw a convex quadrilateral. Quadrilateral means a polygon of 4 sides. So, convex quadrilateral, let us draw. This is a convex quadrilateral. How many diagonals does this convex quadrilateral has? Let us draw. So, this is 1 and this is the second one. So like this we have how many? 2 diagonals we have in this one. Now let us go to B. There is a regular hexagon. Hexagon means a polygon of 6 sides. A regular hexagon means a hexagon which is equiangular as well as equilateral. Let us draw a regular hexagon first. This is a regular hexagon. Let us write the name of the vertices. This is A, this is B, C, D, E and F. Starting from A, let us try to draw the diagonals. Starting from A. So this is one diagonal, this is other one and this is one more. So we have how many? 3. Now let us start from B. Starting from B, let us try to draw the diagonals. So BD is one diagonal, BE and BF. So we have 3 more. So plus 3. Now let us start from C and draw the diagonals. From C, CE, CF. If you try to draw CA, it's already there. So you need not to draw again. So we have 2 from C, 2 diagonals from C. Let us draw from D. So DA, it's already there. DB already there. DF, okay, so DF. So we have 1. So that means in total we have 3 plus 3 plus 2 plus 1. That means 9 diagonals we have. Next one is triangle. First let us draw a triangle. This is a triangle. For this we can't draw any diagonal. So number of diagonals will be 0 in this case. Next exercise 3.1, third question. What is the sum of measures of angles of a convex quadrilateral? Will this property hold if the quadrilateral is not convex? So let us first see what is the sum of the measures of angles of a convex quadrilateral. Let us draw a convex quadrilateral first. So suppose this is a convex quadrilateral. Now what is the sum of measures of the angles? So to know that, let us break this quadrilateral into 2 triangles. So in each triangle we have 180 degree is the sum of 3 angles. Similarly in the second triangle also we have sum of 3 angles equal to 180 degree. So we can say that sum of measures of angles, this is equal to angles in the sense here interior angles. That is equal to 180 plus 180 which is equal to 360 degrees. Now we need to check will this property hold if the quadrilateral is not convex. Not convex means that is concave. Let us draw a concave quadrilateral like this. This is a concave quadrilateral. Now to find out the sum of angles, let us break up this into 2 triangles like this. Now clearly if we take the sum of angles here, here, the sum equal to 180 degrees here, and clearly in the next one also, in the next triangle also we have sum of the angles, this is equal to 180 degrees. So 180 degree plus 180 degree, this is also equal to 360 degrees. So we can say that this property hold if the quadrilateral is not convex also. Exercise 3.1, fourth problem. Examine the table. Each figure is divided into triangles and the sum of the angles deduced from that. You see, in the triangle, there are three sides. The angle sum is 180 degree. In a quadrilateral, number of sides equal to 4. Angle sum equal to 2 times 180. That is equal to 4 minus 2 times 180 degrees. If the number of sides is 5, then that will be 5 minus 2 times 180. If the number of sides is 6, then that will be 6 minus 2 times 180 degrees. This is the sum of the angles. If we observe all these, we can say that the sum of angles in a polygon equal to number of sides minus 2 times 180 degrees. Number of sides minus 2 times 180 degrees. So here you see, what can you say about the angle sum of the convex polygon with the number of sides? So here we have 7. In the first one, we have 7. So the angle sum will be 7 minus 2 times 180 degree. So this is equal to 7 minus 2 means 5. So 5 times 180 degree. This is equal to 900 degrees. Next we see B. Number of sides equal to 8. So sum of angles will be 8 minus 2 times 180 degrees. This is equal to 8 minus 2 means 6. So 6 times 180 degree, which is equal to 1080 degree. Next in C, number of sides equal to 10. So the sum of angles will be 10 minus 2 times 180. So this is equal to 10 minus 2 means 8. 8 times 180 degree, which is equal to 1440 degree. Now in D we have n number of sides. So we can formulate actually like n minus 2 times 180 degree. This is the sum of angles in a n-sided polygon. Then you see, what is a regular polygon? A regular polygon is nothing but equiangular as well as equilateral. So a regular polygon is a polygon which is equilateral and equiangular. That means all the sides are equal and all the angles are also equal. Next, state the name of the regular polygon of 3 sides. 3 sides means it is a triangle. If all the 3 sides are equal, then that is said to be equilateral triangle. So for first one, the answer is equilateral triangle. Then second one, 4 sides. In a quadrilateral, if 4 sides are equal, then that will be a rhombus or a square. But equiangular, then that means all the angles are also equal. That means it is a square. A quadrilateral in which all the sides are equal and all the angles are equal, that is a square. All the angles in the square are equal to 90 degrees and all the sides are also equal. Next, third one. A regular polygon with 6 sides, that is said to be regular hexagon. That is said to be regular hexagon. Next, sixth problem. Exercise 3.1, sixth problem. Find the angle measure x in the following figures. If you take figure A, you see the x is here and the remaining angles we know. We know that sum of the angles in a quadrilateral is equal to 360 degrees. So take the sum of all these interior angles and equalize that to 360 degrees. So we will get x plus 50 degree plus 130 degree plus 120 degree, which is equal to 360 degrees. Now let us solve this equation for x. So x plus 50 plus 130 means 180. 180 plus 120, 300. So 300 equal to 360 degrees. So x plus 300 equal to 360. So therefore x equal to 360 degree minus 300 degree. So that is equal to 360 minus 300 means 60 degrees. That is the value of x. Let us go to problem B. In this you see this symbol stands for 90 degrees. So that means this angle is 90 degree. If this angle is 90 degree, this angle how much? This is also equal to 90 degree. Why? Because these two are linear pair. Sum of angles in a linear pair is equal to 180 degree. Now, sum of interior angles of a quadrilateral is equal to 360 degree. Use that property. So, x plus 70 degrees plus 60 degree plus 90 degree. So, take degrees for all these. Equal to how much? 360 degrees. So, now x plus add the 70 plus 60, 130, 130 plus 90, 220, 220 degrees. X plus 220 degree equal to 360 degree. So, x equal to 360 degree minus 220 degrees, which is equal to 140 degrees. This is the x value in figure B. Now, let us go to figure C. So, here you observe we have 70 degrees here. If this is 70 degrees, these two angles are linear pair. So, this angle will be 180 minus 70, which is equal to 110 degrees. And similarly, here this angle will be 180 minus 60, which is equal to 120 degree. Now you observe this is a pentagon. In a pentagon, sum of angles equal to sum of angles of a pentagon. Pentagon means it has how many sides? 5 sides. So, this is equal to 5 minus 2 times 180 degree equal to 5 minus 2 means 3. So, 3 times 180 degree, which is equal to 540 degree. Now, take the sum of angles. Therefore, here we have x 30, x 120 and 110. So, x plus 30 degrees plus again x plus 120 plus 110 all in degrees. This is equal to how much? 540 degrees. So now x plus x 2x plus 30 plus 120 plus 110. 30 plus 120 is 150. 150 plus 110 260. So 260 degrees equal to 540 degrees. Now from that we need to find out x. So 2x equal to 540 minus 260, which is equal to 280 degrees. From this x equal to 280 divided by 2, which is equal to 140 degrees. Let us go to problem D. You see all the angles are equal and all those angles are equal to x. And this is a 1, 2, 3, 4, 5. This is a pentagon. So, sum of angles in a pentagon. Sum of angles in a pentagon. Angles in the sense interior angles. Pentagon equal to, we know that is equal to 5 minus 2 times 180 degree. So, 5 minus 2 means 3. This is equal to 3 times 180. This is equal to 540 degrees. So, here all the interior angles are equal. All those are equal to x. So, x plus x plus x plus x plus x equal to 540 degrees. So, this is equal to 5x. So, 5x equal to 540 degrees. So, x equal to 540 divided by 5, which is equal to 5 times 1 here, 5 times 1, 5 times 0 and 5 times 8. So, this is equal to 108 degrees. Exercise 3.1, 7th problem. Here we need to find out x plus y plus z. You see where is x and where is y and where is z. Here is x, you see. Here is x, you see. Clearly, as this is 90 degrees, this x will be equal to 180 minus 90. Why? Because these two x are 90 degree. These two form linear pair. Sum of the angles in a linear pair is equal to 180 degrees. So, if one angle is 90 degree, the remaining angle will be 180 minus 90. So, that will be equal to 90 degrees here. Similarly, z equal to 180 minus 30 degrees, which is equal to 150 degrees. Now, y, if you observe, y is the exterior angle in this triangle. Y will be equal to sum of opposite interior angles. So, sum of opposite interior angles, that is 30 and 90. So, 30 plus 90, this is y, which is equal to 120. So x plus y plus z, x plus y plus z equal to, x is how much? X is 90 degrees, plus y is how much? 120 degrees, plus z is how much? 150 degrees. If you add these three, 90 plus 120, 210, 210 plus 150, 360 degrees. So x plus y plus z equal to how much? 360 degrees. Now let us go to the next problem. Here we need to find out x plus y plus z plus w. First let us see x. X and 120, these two are linear pair. So x will be equal to 180 minus 120, which is equal to 60 degrees. Similarly, y and this 80 degrees, these are linear pair. The sum of those two angles will be equal to 180 degrees. One angle is 80, then other angle will be 180 minus 80, which is equal to 100 degrees. Then z. Here z and 60 are linear pair. Sum of z and 60 is 180 degrees. So z equal to 180 degrees minus 60 degrees, which is equal to 120 degrees. Then w. Now here to find out w, we don't know this angle. This is how much? We don't know that angle. To find out that angle, we can make sum of these four interior angles equal to 360 degrees. So suppose this is A, angle A. So then A plus 120 plus 80 plus 60 all in degrees. This is equal to how much? Sum of four interior angles in a quadrilateral must be equal to 360 degrees. So A plus 120 plus 80 means 200 plus 60, 260 equal to 360. So this from this A equal to 360 minus 260, which is equal to 100 degrees. So A value equal to 100 degrees. If A is 100 degrees, then W will be equal to 180 minus 100, which is equal to 80. From that we can find out x plus y plus z plus w. This is equal to x is how much? 60 plus y 100 plus z 120 plus w, that is 80. This is equal to 120 plus 80 200. This is 100 300 plus 60. So this is equal to 360 degrees.